Right, about 3 months ago, I'd started experimenting with this process, cyanotyping, which goes right back to the beginning of the 1840s, and it's one of the alternative photographic processes which I'd long fancied to have a bash at. And I showed, I think, a picture of the moon and one of Copernicus crater, and a few people, or at least one, Andy, expressed interest in this. So I'll put together a little presentation about how I do it, and then most particularly with an emphasis on what not to do or what to be careful of, should I say. You saw me standing alone. So I call this a blue moon and how to make one. My real concern is that you have to work within the limitations of a really quite a limited process and fit your material to it. Otherwise, you can waste quite a bit of material and certainly a lot of time. The very simplest kind of cyanotypes are things like this, essentially tone eliminator. That is, you've got white and you've got a dark blue. The dark blue tone is called Prussian blue, well, that's one of its names, and it's an iron compound. It's quite stable. So once you've made a cyanotype, you don't need to worry about hiding it away out of daylight or things like that. Um, so it's relatively easy to do and relatively inexpensive, but you do have to be a bit careful with it. It is a negative to positive process. That is, if you start with a negative, the print will be a positive, or the other way around, whichever you want to do it. So to get a positive image, you have to start with a negative or create a negative. Now, as you've seen, I think from the images already shown, this is really just for aesthetic appeal. It's an impressionistic image process. It's not fine detail. You're not going to see fine detail in it, and you will only do it because you just like the look of it and fancy to try it, not for fine photographic detail. Now, this presentation doesn't have a great deal of astronomy in it, although I referred to it. It has a very little bit of chemistry and a little bit of photography. It was invented, almost discovered, I suppose, by John Herschel in 1842, that great polymath and inventor of all sorts of things to do with early photography. And he was playing around with iron compounds as well as silver compounds. So this is an iron-based process, not a silver-based process. The first person that we know of who became expert in the use of cyanotyping was this lady, Anna Atkins, who was actively producing cyanotypes for about 10 years between 1843 and 53. She was a friend of John Herschel's, and over that period of time, she produced in installments what was eventually put together as a book, Photographs of British Algae, Cyanotype Impressions. What she calls algae are actually is actually seaweed, various types of seaweed, which she dried, laid on top of coated paper, exposed to the sunlight, and then produced the cyanotype, as we shall see in a moment. Now, this is long before the time of photomechanical reproduction. So the only way that these images could be reproduced, sufficient to produce more than one copy of the book, was to produce more actual cyanotype prints and stick them in, which is what she did. So there are only a very limited number of these produced. It's believed that there are 14 copies of this extant. It's on the internet. If you want to have a look at it, all the images are there on Google or whatever forum you go for. And they're rather nice. And you can see that the prints are nice and evenly coated, nicely exposed, etc. We don't really know much about her technique, but she was certainly a master of the art. And that's the lady herself in about 1861, I think it is, just in the latter part of her life. Blueprints, of course, have been used in engineering and architectural work for a very long time, since the mid 1850s, and they were only finally phased out until in the early 1920s. There was an alternative, the so-called white print, whereby you had blue lines on a white background. It's a variation of the same process, but it's rather more technically demanding. But at least it was available at the time. There's been a modern revival of interest not just in cyanotyping, but in lots of these early alternative photographic processes, perhaps particularly in America, where perhaps they've got a bit more money than we have. But a lot of people in this country are also doing it, and all the other kinds of processes as well. The actual Prussian blue, the sort of deep blue that you get, technically it's a hexacyanoferrate or ferrocyanide or any of the others, also known as Berlin blue, which figures, but also Parisian blue. I don't know why, but there it is, the various names of the compound. And as I say, it's quite a stable compound on exposure to light. People print all sorts of different kinds of subject matter, like an egg on a nest here. But if you look carefully here, you've got the deep blue tone here, and quite a sudden gradation up to really no detail whatsoever in the highlight. And this is the prime limitation of the process. So that's what we have to learn how to do, and steel ourselves and discipline ourselves to work within the process and not do otherwise, I suppose. So that's why I'm calling it cyanotyping by numbers. If you look at a lot of the stuff on the internet, YouTube, etc., people very rarely give you the numbers. They say, yes, you've got to do test prints, blah, 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 but they don't really go into fine details. So I want to do just a little bit of that in a very short time that I've got available. You don't need a dark room for this. You just need relatively subdued light. When I coat the paper, I tend to do it at the back of the kitchen. If it's a very sunny day, I might pull one of the kitchen blinds down, but it's not very sensitive to light. Then when you print it, you actually print it out in the full sunshine if you've got sunshine, or use an alternative source, which is a UV lamp. It's only sensitive to ultraviolet, by the way, or the ultraviolet in sunlight, and really only just the very near ultraviolet, around the 395 nanometer range, for which you can get lights quite easily. If you don't fancy mixing up your own materials, which you can easily get on eBay, you can buy them ready mixed. The chemicals are twofold: ferric ammonium citrate and potassium ferricyanide. I'll just remove the cap, thank you. And this firm called Jacquard, it's an American firm, although you can buy it in this country, and the parts come ready mixed. It's only thin liquids, don't be put off by the cyanide bit here. It's not especially dangerous. It won't hurt you if you get it on your fingers. Certainly don't drink it, but that's all I would say. And you only use very small amounts of it. You can, rather than buying already mixed wet chemicals, you can buy dry chemicals, which is what I did on eBay. I mean, why not go the whole hog and have a bit of fun with the chemicals? You can buy kits of dry chemicals. The orange stuff is the ferricyanide, and the sort of greeny yellow stuff at the back is the citrate. Now notice I put here, you want the green citrate, ferric ammonium citrate. You can get brown stuff as well, which I haven't tried, because everybody says, oh no, use the green. Chemically it's slightly different, and I'm told by those who supposedly know that it doesn't work quite as well, but I can't comment on that really. You only need a very small amount of the mixed up liquid. I mean, I haven't gone into details on this. You actually need, for the citrate, it's a 20% weight to volume solution, and for the cyanide, it's not absolutely critical, but about a 12.5% weight over volume solution, of which you only need 2 mils or 2 cc's of each solution mixed together to cover one A4 sheet of paper. Whether you brush it on, roll it on, I wouldn't spray it on because it can get everywhere, but some people do. This is a coated piece of paper. It has that sort of yellowish look of it. When you've coated it, however you coat it, you expose it. When it's been exposed, you, so to speak, develop it in plain water. There is an image already there. When you put it in the water, you A, wash off the chemical which has not been used, but B, you complete the reaction which has already been taking place in the light, and it brings out the blue image. On the right hand side in this dish here, you can see the image is rather paler blue than it is in the one in the center. This is the tap water, which is all you need, and this one has an added ingredient, which is hydrogen peroxide. If you left that paler looking print just in the open air for a few days or a week or two, it would gradually oxidize and go the darker blue on its own account, as it were. But most people put in a bit of rather very dilute hydrogen peroxide, just a few drops. Here they're dropping it straight onto the wet print. I wouldn't do that. You can see it starts to all fizz up here. I would just put it into a little dish of water, swish it about, and then put your print into that. And in a very few seconds, it comes up in the deeper blue coloration. This is an example of what you get. This is the very simplest kind. It's called a photogram, really. I've just put three bird feathers and an old oak leaf on top and exposed it to light, and then put it into a dish of water. Now, what about the kind of paper to use for your prints? Well, I've said there, brackets transparency. You can actually use a transparency for your negative. I won't talk about that except in passing. You know, an acetate transparency, which you create either on your inkjet printer or on a laser printer if you have that. I'm really thinking here about using paper to provide both a negative and a print. In terms of the other tools, you don't need much, as I say, perhaps a sponge brush or an ordinary brush or a couple of dishes. I have got photographic dishes, which makes it easier, but you don't have to use that as long as you rinse them out carefully afterwards. I put here possibly oil or wax. What I'm talking about here is the paper negative. Obviously, if you've got a sheet of paper for which you can use ordinary like computer printer paper, and you print your negative image onto that, it's not going to let a lot of light through to get to the print underneath. But if you oil it or wax it, it will make it much more translucent. And I found, by measuring with a light meter, that it only then stops about 1 stop's worth of the light passing through it. That is, it halves the amount of light passing through it. Now, in terms of light sources then, you can use natural daylight, sunlight. But of course, in this country, you can't guarantee a clear blue sky with sunlight. If you could, and I have used sunlight, fine, that's all being well. In principle, you could use a cloudy day, except it will take at least twice as long. But the problem is the cloud might be variable, and it might be variable during the exposure, and you really don't want that. You could, on the alternative, use an ultraviolet light. Some people make their own DIY UV lights using UV LEDs, again, off eBay, and there's lots and lots of videos on YouTube about making your own UV lights. Here's one that somebody made. Here's another one with the strips lit up and connected and the voltage going through them. This one's been put into a wooden housing, but rather elegantly, but there are all sorts of ways of doing it. You don't need to be as sophisticated as this. What you do need to remember is that if you're using daylight, you can measure the light with a light meter, photographic light meter, should you still have such a thing. But to get a meter which works for ultraviolet, they're a couple of £100 or more. And I'm not up to laying out that sort of cash. So really, you can measure the light if it's daylight, sunlight, with a meter, and if it's, say, a little bit hazier, you just allow a bit more exposure according to the meter reading, just as you would if you were taking a photograph. But for the UV lamp, you really just have to do straight test exposures and find what works. And I'll come on to that briefly in a moment. Now, the main problem with cyanotype is its lack of exposure latitude, by which I mean the breadth of light to dark that you can get in an image and still preserve detail. I've got a series of sort of film exposures here, but digital is very much the same. If we take this one here to be your basic exposure, decently exposed, if you go as many as 4 stops underexposed, you can still see some detail, at least in the highlight areas. If we go the other way and overexpose the light, overexpose the image, then you can still see some detail 4 stops overexposed. So you've got an 8-stop range here over which you can still see some detail, even though the best one is that 60th at f8, as you can see there. But there's a major limitation with cyanotypes, which is that from the measurements which I've taken with the light meter, it's only got approximately 2 stops or 2 to 3 stops at maximum exposure latitude. If your exposure range, if the range of light and dark, shall I say, in your negative falls outside that, then you're going to sacrifice detail at one end or the other, depending on the length of your exposure. And the range of exposure that you need, shall I say, the range of light and dark that you've got in your negative, I actually work out according to a meter. In other words, I measure the actual amount of light passing through the negative into the meter before I actually make the exposure. That's doing it by the numbers. In terms of daylight, if you're using daylight and it's full sun and you can just measure the daylight, I do it with one of these meters. I've had it for, I don't know, donkey's years, decades, a Western Euromaster. And the white cone there, called the inver cone, goes on the back. You point it towards the sun, not towards anything else on the ground, and you are taking what's called an incident light reading. You're measuring the strength of the light source, in this case, the sun. So, and you gauge your exposure according to that once you've done some trial exposures to find out what's going on. The other meter that I use for measuring the light passing through my paper negative, if it's an acetate, I'm taking that it's clear, so you don't need to make any allowance for the actual light being stopped by the acetate, though you still need to measure the difference between the lightest and the darkest parts of the negative. This CDS meter has a little window at the front there, which I can sort of hold over the paper negative and measure the light passing through it. And it's rather more sensitive than the other meter. And I'm measuring the light transmitted by the image, that is let through the image, daylight let through the negative image into the light meter. Okay, in terms of practical terms then, you coat the paper. Now, you do this, as I said, in subdued light. It doesn't have to be done at night, doesn't have to be done in a deep, dark cupboard or anything like that, or the coal cellar, just as long as there's no bright light in the area. Once you've coated it, you must dry the paper thoroughly. If you've got a hairdryer, it can take maybe 6 to 8 minutes. You'll know that it's getting near to perfectly dry because the paper will curl up at the edges. That's not a problem when you put it into the printing frame. I bought myself a little 200 watt so-called fan heater Chinese job, and that takes about 6 minutes, depending on the kind of paper that I'm using. I built a little, well, I made a cardboard box with a hole in the top. I put the fan heater on top of that with the coated paper underneath, let it blast through for about 6 minutes, and that does the job. If you don't dry it thoroughly, the danger is that the reaction will take place as soon as you put it underneath the light source, and it may come up rather patchy, and you don't want that. Now, what about preparing the actual negative for printing? Here's an ancient image that I took a long time ago with a webcam of Copernicus crater. Now, you need to convert your image, if it's not already grayscale, into a grayscale image. The cyanotype is only sensitive to that sort of very far blue, near ultraviolet range of colour. It's not sensitive to any other colours, so there's no point having any to confuse things. Once you've converted it to grayscale, you need to think about adjusting the tonal ranges, tonal values in your negative to be, so that you don't exceed, if at all possible, this 2-stop range. You might even, if you've got a light meter like that CDS meter, you might even measure the brightness of the image on your monitor screen. I don't see why that shouldn't suffice for these purposes. Once you've done that, you need to invert the thing to produce a negative. But you also need to reverse the image itself. The reason being that you need to flip the image horizontally, because the actual printed side is best put in contact with the coated print surface. You won't make an awful lot of difference with a thin paper negative. It's just that that's generally thought to be the best thing for the crispest resolution, not that it's going to be particularly crisp. Anyway, you print out your negative, be it on acetate or on normal computer printing paper. And then you have to think about preparing your paper negative, not the acetate one, that's fine as is. Prepare your paper negative for printing. That is, are you going to wax it or oil it to increase the amount of translucency, increase the amount of light that gets through it? Here's some examples of what you might do. On the left here, this is actually beeswax. Or wipe some paraffin on it, or some Vaseline. Castor oil doesn't seem to work so well. I use cooking oil or rapeseed oil or anything like that. Just wipe it on. Now, these are somewhat messy processes, and it's best to remove as much of the excess wax or oil or whatever it is that you use as best possible. Now, the thing to do is to coat not the image printed side, but the opposite. If you coat the image printed side, the image itself might start to wipe away if you wipe away the excess oil, say. So print it on the other side. You might want to sort of blot it off with a slightly warm iron with some kitchen roll on top of the actual oiled side. But I would further suggest that you actually leave the negative for 2 or 3 days to sort of dry off better, as it were. If you put it into contact with the print too early, and especially if you put it out in daylight, it's going to get hot, and some of the oil, residual oil, will transfer to the print, so it's best avoided. UV is not so bad, but even they can get a little bit warm, so leave it a few days if you can. Once you've coated the thing, you need to calibrate the thing. How long should your exposure be? Here's a test stepped exposure, the least exposure on the right, as you can see under the full negative. And it doesn't say here what the intervals might be, but typically that might be 20, 40, 60, 80, whatever minutes of exposure through a waxed paper negative. If it's an acetate, it's going to be about half that. Now, the characteristic of the cyanotype is roughly like this. It gradually builds up the depth of tone, or will do when you develop it, and then reaches the maximum density, max D as I call it, after which it does very little. Even if you expose it longer, you won't get any deeper tone. So you're looking for the length of exposure at which it reaches that maximum density. And that will be your guide exposure for your main exposure of the negative onto the coated paper. But that said, it does depend on the kind of paper you're using. Now, I've used predominantly, I've tried all sorts of things. Computer printed paper would work, but it's too thin, it's too flimsy. And once you get it in the wet, it tends to sort of come apart. So I've used watercolor paper. The cheaper stuff is from Wilko. I get A3 pads because it works out cheaper. And if I'm doing an A4 print, I just cut them in half. I also use the De La Rowney stuff. That's about 3 times the price of Wilko, and it gives a somewhat different result. The De La Rowney reacts to light more quickly, and it produces a deeper tone, deeper max D, but it comes to this shoulder, as it were, quicker, after which it just doesn't increase its density. So you have to be careful. What this means in photographic terms is that it's a higher contrast working imaging paper, if you like, than is the Wilko, which can give you some difficulties. Here's that rough image of Copernicus, which I did some time ago. And you have to work up what is your maximum density of maximum blue from your test exposure. And then you can do a full test print, just stepping it a little bit with less exposure, that exposure, and a bit more exposure either side, and that will give you a better guide as to what is the correct exposure. Now, this chap has done 3 exposures. On the left, clearly underexposed. He says that's overexposed, and he says that's good. But if you look at the one on the right, it doesn't have the density of blue that the one in the middle has. Now, I would say what he needs to do is to go back to his negative and reprint it, modifying the negative so it's not quite so contrasty. Then he can still go for his maximum blue without him blowing out the highlights, say. So judgment, personal judgment is still required on what you think is the best print for you. I mentioned in passing that you can't do dodging on this. That is, if you've ever done wet process darkroom photography, you can stick your hands and fingers in the light beam of the negative going down onto photographic paper and shield one area, which is called holding back or dodging, or else create a hole in your hands and give an extra another area extra exposure, which is called burning in. Well, if you've got a 40 or 50, 60 minute exposure, you can't hang around doing that. So as I say, that's not really an option. For my exposures, I find with my meter, yours may well be different, that if I don't have a negative on top, or if it's just an acetate, in sunlight, it works out at about 23 minutes. With a paper negative, with like this one of the moon, you can see it's translucent, it blocks out one stop worth of light. In other words, you have to double up that time from 23 minutes to about 45 minutes in that same strength of sunlight. That's the meter reading I got with my particular reader, your meter. Yours may well be somewhat different. If it's a bit of a hazy day, the meter reading isn't quite as high, well, just like an ordinary photographic exposure, you can vary the required exposure is the same. If that 12.3, for instance, had been 11.3, but it was still sunny, but hazy, but constant, you would have to give an extra stop. That is double the exposure from what it was before. But the principle is the same. But the issue is that the light source must be constant, which is often is not the case in our country. You might get cloudy bright conditions. You might get cloudy conditions with varying cloud. You might get everything all together, including rain, which is no good at all for our purpose. We must have a constant light source. If the light source is varying, so will the exposure be varying, and we won't know where we are in terms of the actual maximum exposure that we need. If you use a UV lamp, as I said at the beginning, you can't meter it unless you've got a specialized meter, but it is at least a constant source of light. Now, in terms of exposing the making the print, I got an old A4 photo frame here. If I flip it over, then I cut the hardboard back in half, stuck a bit of duct tape on with these fasteners. The idea being that you could sort of lift one side, flip the print up if you want, and see how it's getting on. I made this for doing a different kind of photographic process rather than cyanotyping, so I don't actually bother to lift it, but you can in principle do that. So your negative will go onto the glass with its print facing outwards or downwards towards the coated paper surface. The coated paper goes on facing outwards, as it were. You fasten the thing up and there you go. This is the UV lamp that I use. It's a nice waterproof one. I got two of these 50 watt a piece from Amazon, I think it was, for 40 odd quid. But I've subsequently realised you can get a 100 watt lamp for 13 quid off Amazon, which is a bit of a peeve really. Granted, it's not waterproof or whatever, but you could that's really quite inexpensive. And that's a very good buy, I think. And at 100 watts, you'd only need half the exposure time, of course. In fact, you could buy a couple of these, 4 of them even, and cut your exposure times drastically thereby. So here's a chap who's made the negative. I think it looks like either an acetate or a glass negative, and made the cyanotype print on the right-hand side. We've gone through creating the negative on the computer and printing it on the acetate or the paper. Here's our moon image again. Now, I've only mentioned thus far acetates or normal computer printing paper, but there is a third possibility, which is tracing paper. The sort of tracing paper that you get these days is sort of plasticky stuff, and you can see that it blocks very little light going through it. You can see here, I said it only knocks off half a stop in sunlight, or the same would be for UV. The problem is, how do you print on it? It will not take, I have found, it will not take inkjet printer inks. It will, however, take laser toner. So you can get a print on that, but make sure you have some other paper in the tray and put the tracing paper on top of it. Otherwise, it might get lost somewhere in the works. You don't really want that, but it does work, and it's a nice option to try. As I say, it's for the laser printer only. If your negative looks rather thin, even after you've sort of manipulated your tones on the negative, you can always print out another one and stick the two together in register with a bit of sellotape or whatever. Make sure they are in register and print through the two together, and that will give you a stronger looking final image. This is a little light pad which you might use. I just use the light through the kitchen window to measure the different tone densities of your negative and decide on your exposure accordingly. Once you've made the thing, you put it out for exposure, like I have this nice image of these cats watching this huge comet. In colour, there's a nice difference in tone between the cats and the sky background. Not so good when you see it as a negative. And when I actually made the print, the cats virtually disappeared. So really, I should go back to working on the negative and adjust the difference in brightness between the two areas, or else just give a shorter exposure so I don't sort of deepen the tones of the cats too much. As I say, you will get through a few sheets of paper doing this. And try not to exceed that 2-stop range limit, which we're clearly doing in this image here, the sunlit crater wall and the debris field around here. Much more than 2 stops difference, but you might measure off the screen to make things easier for you before you actually make the print. Here's our image of the moon. Here's one print I did from the image, and here's a second. Sorry about the blotches, that's my imperfect brushing. I'll just go back to that. You can see that they're very different. Here on this one, with much lesser exposure, that the highlights are blown out, but on the other hand, we have retained detail around here, which we've lost in this area here. So it's horses for courses, but I think perhaps somewhere between the two might have been their best exposure. This is the negative. After I manipulated it, I'd lightened the tones in the dark areas and darken them slightly in these highlight areas to try to preserve a bit more tone on the final result. But as I've said, the density of the blue and the contrast does depend on the kind of print paper that you use, and you just have to experiment with that. This is the Wilco version, and this is the Daler Rowney. The Daler Rowney gives you a deeper tone than does the Wilco, but the Wilco preserves detail in some of the highlight areas, such as the trees, the clouds here, and the grass, which are blown out on the Daler Rowney, even though everything else is sort of correct, as it were. So you've got to be careful with your negative and choose your paper accordingly. Here's one of M31. Here's a step test print done in quarters. This is a wet print, hence the sort of glow here. It's still reflecting the daylight. This is it after it has been peroxided, but you can see the exposures that I had to give this. This was under the UV lamp, by the way. So somewhere between 60 and 80 minutes, there's very little change. So you're looking sort of this range to give the actual print. And this is a print I did from that. As I say, it's impressionistic. You can vary the exposure according to your own likings, and that's all I can say on that one. So you need to do a test print to establish your base guide exposure on your coat of paper, and a proper test print for each actual print to make sure it is doing what you want. So you might end up doing 3 prints. Here's the moon again, split into quarters with different exposures. You can see the maximum densities between these two. When the peroxide is on, the maximum density again is here, but it looks a little bit dark. So an exposure perhaps between the two will give you this sort of result. You can of course scan the image onto your computer and manipulate the final image accordingly, which is what I've done here, and perhaps print it out. And here's the scanned Copernicus onto the computer and played around with on the machine. And here I've added a sort of texture filter. I think this is called dream smoothing, just to give a bit more, arty, surreal effect or whatever. But you pays your money, you takes your choice. NGC 4565. Again, very much an impressionistic result. I just mentioned in passing, you can print on textiles as well. Just be careful when you wash them. Don't wash them in modern washing liquids. They're much too strong and chemically active. Just very weak soap. Avoid all these phosphates and things like that, and try not to wash them too often, because the Prussian brew will wash out eventually if you're not careful. So it's still a matter of personal testing and judgment. And but if you fancy to have a go, it might give you some meaning and purpose to your retirement, dare I say, as it has mine. So I think that's about it from me. There you go.
Good.
Very good.
Excellent.
Very good.
I always put in something daft. I can't avoid it, can I? Right.
Has anyone got any questions for Ray? Preferably something that he can't answer.
I'm terrified by this Ivers picture. My goodness, what a thing to come home to.
Go on, Bill.
Oh, Ray, that was fabulous. Thank you. At the very end, you showed some printing onto fabric.
Yes.
And you say it's difficult. It doesn't take very well. Have you tried a mordant like alum?
Yes, I tried mordants. I've cut this down to the minimum for this little presentation. I've tried all sorts of things, including alum mordant on both paper and fabric. And I've tried all sorts of combinations and concentrations and additions of other chemicals. And long story short, no, it doesn't help. You would have thought that it would, but nobody else was referring to on the internet, on YouTube, to using mordants. They do for dye printing, obviously, but not for this. And I realised why. If anybody's ever tried it, they thought, well, it's not worth the effort. But yes, I have tried it, and it leaves streaky results on paper, which you either like or don't like, but they're a bit uncontrollable. But it didn't seem to help with the actual fixation of the chemical. The chemical it created and, as it were, bonded into the paper fibres or the fibres of the fabric, and it will stay there. It's not that, if you rinse it in water, it's not going to come out. Certainly not in the fabric. But it's with the fabric, it's best to try it with spare pieces of fabric which are very much the same as a t-shirt or whatever, because if a t-shirt is costing you a minimum of £5 a time, say, you don't want to be wasting your t-shirts, do you? And you have to be very careful with masking off the area that you want to print on the t-shirt, otherwise you get blobs and stuff all over the place. And clearly you need to put something liquid proof underneath the front of the t-shirt, so the chemicals don't go all the way through onto the back. You can print the back separately. Just be careful with it and dry it properly, etc. Apart from that, the processing is just the same.
I saw an episode of Rough Science a few years ago where they used urine as a mordant as well. That was quite effective.
Well, yeah. Well, when up at Whitby, the side of Whitby on the north side, Sands End side, there are some old iron mines, and that area used to be heavily quarried for alum. What they used to do was they used to take coals from Newcastle, and they would bring barrels of urine, barrels of urine back up to Whitby, drop them off, and that was used as part of the process, the chemical process, for boiling up with these alum salts compounds, and then they would extract the final chemical from it. And you can still see the remains if you go up there today. But yes, not very nice, but there we are.
Alternatively, Ray, you could just not bother with the mordant, scan your original image, put it onto a memory stick and take it down to one of these
You're
to
cool.
print
Of
them
course,
on T-shirts.
where's the fun in that, lads? No, because
Well, I knew you were going to say that.
well, when I used to do wet photography, and I haven't done it for 25 years or more. I knew about all these processes, being interested in the history of photography, and I thought perhaps one day I'll have a go at it. I thought, well, I'll be dead soon. If I don't get on with it, I'll never do it. So I thought, yeah, let's go. Actually, the first one I tried is called anthotyping, where you don't use special chemicals. You use plant juices, anthos from Greek flower or vegetable, and you can either mash it up and extract the juice in water. I found that nothing worked reasonably well at all, apart from turmeric, the spice, which is very heavily sort of that yellow orange coloured. If you mix it up with alcohol and squeeze it out in kitchen towel or whatever, and then you can coat your print with that, put your stuff on top of it, lay it out in the sun, but that takes many, many hours. And that's a positive to positive process. That is, whatever you stick in the way and block the light, it will be white underneath and the rest will retain that yellowish colour. You then stick it in a bit of borax to deepen the tone, and that's it. So I tried that, which is all right, it works, although you get very yellow stained fingers. And then I went on to the cyanotyping, proper chemical stuff after that. So the next thing I want to try is salt printing, whereby you have to use salt, common salt, sodium chloride, and silver nitrate to produce a much more sensitive medium piece of coated paper. And then after that, you try the color typing, where you use similar chemicals plus a bit of other acids, etc., to produce an even more sensitive piece of paper, which you can actually put in a camera and take a picture with. But that's for the future.
The kit of chemicals for cyanotyping that you say you can buy,
Yeah.
I don't suppose that includes the hydrogen peroxide, does it?
No, I think the kit in this country is something around the 20 quid mark. Obviously, I didn't pay that for. I maybe paid 8 or 9 quid for the dry chemicals. So if you want to avoid the faff and palaver, yeah, by all means buy the ready mix, because as I say, you only use very small amounts of it. It will last a very long time. The peroxide I got off eBay again, the peroxide I got was 9%, which is plenty strong enough, and I use maybe 0.5 ml, something like that per print, tiny amount. You don't need anything over 12%. Is a bit hazardous, really, but you can get 6% or whatever. It works just as well. It's not critical.
Any other comments or questions from the
Sorry, Ray.
assembly?
What was the other chemical that you mix with ferric ammonium citrate? What's the other one? It's something cyanate.
Potassium ferricyanide. It's the photographer's standby. We used to use it for black and white photography for all sorts of things. Right. So that's the sort of reddish brown crystalline stuff. And the ferric ammonium citrate, you want the green powder version or the green version. And
sorry, it's the green ferrous rather than ferric.
It's ferric.
They both are.
Yeah, they're both ferric. Yeah. I just weigh it out little bits on the kitchen scales, which are quite accurate, on the grams setting. But as I say, if you buy the stuff ready mix, you don't have the hassle.
Okay. Well, thanks again, Ray. Absolutely intriguing.
I'm sorry I hold on for